Hi, I'm Mary Chibb with Bentley Systems. Today I'd like to show you how to make a parametric cell for a door panel in your curtain wall system, similar to the one seen here. So this is a double door that is placed as a panel within the curtain wall system. And today I'm going to create a corresponding single door. So I'm going to go ahead and open up my cell library. So this is our mullion profiles cell library. So we store the mullion profiles for the curtain wall as well as parametric panels in this cell library. If I open up the models, you can see there's a number of models or cells within this file. This one here is that door cell that we just saw, and we're going to create the corresponding single door. So I'm just going to create a new model. We'll start from scratch and go through the process. So I can come over to my models and create a new. Of course, it'll be a design model, 3D design model. I'm not going to use a seed. Now the naming of this model is important. I'm going to do face underbar for underbar definition. And then underbar and put a description. This part right here is important. All the parametric cells must start with face for definition. 4 indicates the number of sides on the panel. So typically 4, it's possible you might have 5 or 6, but for a door, of course, it's going to be 4. And I'm just going to call this my single door. The other important note is that you have to have this toggled on. It can be placed as a cell, and the cell type should be set to parametric because we're creating a parametric cell. And I'll select OK. So that opens up a new model. I'm going to switch my display style to the white background. Just make it a little bit easier to see. And I want to locate that 0, 0 origin of the model. I'm going to work here in the ISO view. The 0, 0 origin will be the origin of the cell, and that's important. That needs to be the lower left-hand corner of our panel. So I'm going to start. The first step is going to be to draw a rectangle that represents panel. So I'm just going to bring up my level attributes and go ahead and select the default level. That's not mandatory, it's just not a bad level to put something that's a construction on. And we're going to start by making that rectangle, which is really a construction. And I'm going to go ahead and just set a color. I'm going to use a dashed line style and a weight 1 so that we can see it here easily. And then I'll just use the place block tool. I'm going to, as I said, start at the 0, 0 origin. I'm going to rotate my compass to front. I'm going to draw this in a front elevation, the same way it would be in the curtain wall. Now, the panel will be parametric. In other words, we'll be able to resize that rectangle to any size panel, but it is important when it's stored in the cell that it's essentially its smallest possible size. In other words, we can size it up parametrically. We won't be able to size it down parametrically. So this is a door cell. I'm going to say 2 feet. And then we'll go up 6 feet. I'm not going to have a door any smaller than that. So that'll be my starting rectangle. Now, in order for the software to know that that rectangle represents the panel, we need to put a family and part in it. And that family and part needs to be curtain wall, curtain wall. And so I'm going to set my family and part, select apply part. I don't want to change the symbology. We just want to get the part on there. So we'll go ahead and do that. If I hover my cursor over that, I can see that that was applied. I'm also going to add a couple of constraints to this rectangle. So constraint modeling means we build constraints on the geometry so that it behaves in a certain way. So there's a couple things about this rectangle that we want to make sure happen. For instance, we always need that lower left corner to be at the 0, 0 origin. We don't want to be able to move that rectangle off that origin. So I'm going to come up here to my Constraints tab. This is where I have different constraints that I can apply to my geometry. So the first one I'm going to apply is a fixed constraint. So I just select it, and then I come here and snap to the point that I want to fix. And you'll see that little red crosshair indicates I'm at the vertice, and left click to accept it, and we can see that fixed constraint there. And what that means is if I were to select that rectangle and I have handles, right, I could move this edge, but if I try and move this edge, it won't move because it's been fixed. Let's undo that. Now, another thing I want to constrain about this rectangle is that these corners remain perpendicular. You saw how here I was able to move that vertex, and now I have non-perpendicular corners, and that really wouldn't work for a door. So we're going to use our perpendicular constraint, and I'm going to constrain 3 corners. And if I have 3 corners constrained perpendicular, then the 4th will also be perpendicular. So that gets our rectangle constrained that represents our door panel. Now we're going to start setting up some geometry for the actual door. So this door is going to have a frame, top and bottom, and then glass in between. It's a fairly simple door. And I'm going to first create some 2D geometry, and then we'll extrude that geometry to create the solids we need for the 3D geometry. So again, I'm going to use the Place Line tool. First, let me match my attributes there, and we'll do the Place Smart Line. Now I'm going to just draw 2 horizontal lines, one at the top, one at the bottom. I'll use my nearest snap to make sure I'm on the line, and then just draw across to the other side, and we'll do the same at the bottom. So we now need to constrain these lines. We can use a parallel constraint, and we simply select top and then the next line, and now those 2 lines are constrained parallel, and we'll do the same at the bottom. Now the second one is that we want the end points of this line to always fall on this line or that line, and we can do that with a coincident constraint. So I'm going to select the coincident constraint, I'm going to snap to the end point of the line and then to that line. End point of this line and then that line. Do the same there and same here. And now if we were to test this, and I'll adjust that rectangle, and as I make that wider, the horizontal lines grow with it. However, if I make it taller, it increases that spacing there. I actually want to control that spacing. So that's going to be the next step. So let me undo those changes. And what we're going to do is put a distance constraint. In other words, we're going to define that distance between the top of the rectangle and our frame. And we could put in a fixed distance. We could say make it 6 inches or 4 inches. Or we could actually create a variable for it. And that way, with this same door cell, you could create multiple variations with a different frame width. So I'm going to open my variables dialog. And I can create these different local variables to use within this cell. So I'm going to add a new variable, and I'm going to call this one frame width. And we'll start with it at, let's say, 4 inches. Now, I'm going to create a couple other variables. One is I'm also going to have to create a thickness for this door, or we're going to call that the frame depth. So I'll create another variable and name it frame depth. And I'm going to set the frame depth at 1 3/4 of an inch. And I'm going to create one more variable. I may not use this variable, but oftentimes you need a variable like this because when you start extruding the 2D geometry to create the solid geometry, sometimes you're extruding something in 2 directions to create the width or this depth, frame depth, and you have to remember our panel, that shape there is always the center line of our door or our panel. And so oftentimes we need sort of the half. We want to take that frame depth and divide it in half. So we're just going to create another variable for that, and I'm going to call it frame depth 2. And then it's still a distance variable, but rather than just type in a value for it, we're going to create an expression. So if I go to the 3 little dots, I can open the expression builder, and here's where I can build expressions, basically mathematical expressions. So for instance, if I double click on one of my variables, frame depth, that puts it into the field there. Then I can use the divide symbol and we'll put in 2. So we're going to take the frame depth and divide by 2. We'll test it. Tells us it's valid, and we're going to select OK. And you can see there it's grayed out, but that's going to be 7/8 of an inch. So I can't change that because it's based on the actual frame depth. And that's the 3 variables I need right now. So the first one is to set this distance here. So I'm going to use this distance constraint. I'll select the top, and then this line puts a dimension in there. I'm going to left click to accept. And you can see here I can either type in a dimension, hard code it, or I can pick one of my variables. So I'm going to select frame width, hit the enter key, and it's going to adjust that line so it's 4 inches just like the variable states. And we'll do the same thing at the bottom, frame width, and accept that. So now we have basically the 2D geometry set up, and we can start creating the 3D model. So I'm going to start with the frame top and bottom. So first I'm going to change my family and part to my curtain wall frame 1 part. I'm going to switch over to the modeling workflow, and I'm going to go to the solids tab. And so we're going to be using some of these tools, this extrude or thicken, so we can take the 2D geometry that's there and extrude that into solid geometry. I'm going to select that. Let me go ahead and close this. So we'll use our active attributes. We'll keep our original. This will be parametric. Now the distance, so we're going to take this line, and the distance is how far we're going to extrude up from that line. And we could, again, hard code in a dimension, or we can use our variable. So I'm going to select the variable, select frame width, we'll select OK. And then the thickness, we'll give this a thickness. We're going to use that frame depth, and it will be centered along our linear element. Now there are a few other options. We do want to create this orthogonally, but we do not want to extrude in both directions in this case. So then zoom in here, I'm just going to select this line, and then I always like to rotate my compass to front and make sure I extrude up. So that's the top piece, and then we'll do the same at the bottom. This time we'll extrude down. Now it did pick up my dashed symbology. I'm going to just change my element attributes here. Now you can also use any of your other feature modeling tools, such as we could chamfer some of the edges of that. So let's say I'm going to put a 1/2 inch chamfer on my edges here. Just a little more detail on there. So that takes care of the frame. The next piece would be the glass that spans between them. So I'm going to go back to my Surfaces tab. I'm going to change my family and part to my glazing type 1. And I'm going to use the Loft Tool. I'm going to go ahead and hide the profiles, and of course keep this parametric. So I'm just going to select that bottom and then the top. So that creates a surface. Then I can go back to my solids and I can thicken that surface into a solid. I'm going to thicken in both directions and I'm going to give it a thickness. I'm going to use 1/4 of an inch. Again, we could create a variable for this, but it's only necessary to create a variable if it's something you think you might want to create different variations of. And so all I'm going to do is select that surface. You can see it there that I already created. You can see it's going to go in both directions, and we're going to left click to accept that. And that has created the surface. Again, I'm going to have to go back and change the attributes. It already has the family and part, but I want to get those default attributes on there. So that's essentially our door panel. I'm going to add one more element to this, which would be a door pull. So that could actually be something I've modeled as a cell, a static cell, so to speak. And we just have to place it here on our profile. And as long as we use the association when we place the cell, it will also move and adjust with our shape here. So this is the door pull I already created. That's the cell there. I just put it here in this same cell library. So I'm going to go to my Content tab, Place Active Cell. I've already got that door pull selected. And I'm going to put my angle at 0. This will be the hinge side, so I'm going to put my door pull over here. I have true scale on, and this is, I want to have that association ticked on. And then I just need to find the center of my outside edge there and place that door pull, and we can see that there in the plan view. So we basically have all the elements of the 3D model. What I still need to add to the cell is the 2D symbology for the door swing and the door frame. So that'll be the next step. So I'm going to change my family and part. I'm going to start with the door swing. So I'm going to use the 2D door swing part. And we're going to place an arc. And we're going to use start and a center. So my hinge is over here. That'll be the center. So I'm going to start here at the edge of the frame and then come over here to this edge and then just rotate that 90 degrees. So that gives me the arc, and then I'm going to switch this to the plan and we'll do the door as a rectangular block. And I'm just going to start here at that same corner, come up here to the edge of our door swing, and then I'm just going to make this 2 inches for now. We'll adjust that width in a minute. So we have that 2D geometry drawn, but we need to get it constrained because it also needs to adjust when we change the size of our panel. So I'm going to start with the arc, and one is we need to constrain the center of the arc so it's always on this corner of our frame. So let me go back to my constraints, and there's a concentric constraint. So I'm going to use that one, and I'll first select the arc so it finds the center of that arc. And then I want to select the corner of the frame, and I want to make sure I'm getting the frame and not like the corner of this shape because that's not constrained yet. So we get that constrained on the frame. And then I also want this start point to always be on that corner, and we can do that with a coincident constraint. So again, I want to make sure I get the end point of the arc and then the vertex of the frame. And it should be then that if I were to make my rectangular shape larger, my arc also gets larger. So the arc grows with that as it should. Now I got to get the door linked to that. So let me undo that. We're kind of going to do the same thing. We're going to get this corner coincident with that. So I'm going to select that and then that. I also want to make sure that it maintains itself as a rectangle. So just as we did with the original shape, I'm going to make the corners perpendicular. So we'll do that one, and that one. And then I also want it to grow. If the door gets bigger, then that representation needs to get larger. Basically, it always needs to line up with my art. So we can, again, use the coincident constraint and make the end point of that line with the end point of the arc. And finally, I'm going to put a distance constraint to control the thickness of this door. And we can basically use our frame depth. And now, if I select that shape and adjust it, we can see our door symbol adjust as well. Now, one additional constraint I could put on here would be the angle of the swing, so that if we wanted to do a 45-degree swing, we could create that variation. And all I need to do is add this angle constraint and create an angle between our frame and the edge of our door. I'm going to select angle, select the edge of the frame, the edge of the door, and put that angle in. We'll go ahead and put it in as 90. But let's go back to our variables and create another variable for the angle. So I'm just going to call this angle. And rather than a distance, this would be an angle constraint. And we could put a value in here. So let's try 45. And then we'll go back and we'll, again, edit this dimension and select our angle variable. And now you can see it creates that door swing at a 45. And if I were to change it to 60, it adjusts that. Then I'm going to create some variations for different cells. So for instance, maybe I want a frame width 5 inches with an angle of 60 degrees. So we'll create that as a variation. I'm going to add that. So I'm going to call that frame 5 and swing 60. And then maybe we want an option with a 6-inch frame, and we'll change the angle to 90 for that one. And you can see our cell is changing there, and we're just going to add that variation. So that was frame 6 and swing 90. And then I can apply whichever variation I want to see. Now, a couple final things. One is that I don't want my shape here to show up in my actual 3D model, so I'm going to make that a construction class element. And all of that line work, I use that orange Symbology. So an easy way to select all of that would be to select by color. So I'm just going to select my color 6 and then do a change attributes. And all I really want to change here is this class and make it construction. And I can check that I've done that correctly by turning off constructions. I can see I've got a problem. I inadvertently built some of the model as construction class. So again, I may just want to change element attributes and make sure everything that should be a primary class element is. And let's double check that again. If I turn off constructions, I still have my 3D model and my 2D symbology. So that's good. And then the final step is we need to indicate the geometry that's the 2D symbology. And we're going to do that with named presentations. So I'm going to go back to my building design workflow, and I'm going to select this named presentation dialog. And you can see here, right now, all the elements are under the model category, meaning if we have named presentations turned on, that's what would show up in the model view. But what we want is that this 2D symbology shows up in a top or bottom view. And so we're going to move those elements to this top and bottom view. So we're going to say add to named presentation. We're going to select top and bottom. And then we're going to select these two elements that we want, the door and the swing. And we can check that by turning off the visibility, and we'll see those two items go off. And if I turn off the model, all I have left is the 2D symbology. So that's good to go. And then finally, we're going to create the data group catalog item and link to this cell. So I'm going to go back to my data reporting tab, open the catalog editor, and we'll add a new catalog item to our curtain wall panels. I'm going to call this XYZ underbar, and we'll just call this my single door. Save it in the workspace. Now the panel type, we need to set that as a parametric cell. For the part, family and part, I'm actually going to select door here and door. And that's just, will make it easier to sort out the doors when or filter out doors when I'm creating any kind of schedules or reports. Put the door thickness in there. And then we need the profile would be the cell. And so we're going to select that. I'm going to find my cell library, the mullion profiles XYZ. And here's my single door, and then these are the two variations I created. So I'm going to select that first variation and select OK. And that's all I need to do to set that up. I'll do a save. And now that's linked to that catalog item. So let's go back to our 3D model. We'll go ahead and place this in the model. So let's place a single door here. And I'm going to first copy this frame over 3 feet. And then I'll place the door in here in that panel. I'm going to first hide the bottom frame. I won't need that with a door in there. Then I just select the panel. I can modify its properties, and we're just going to switch the panel. So instead of our typical glazing, I see my single door that I just created. We'll go ahead and apply that. Left click to accept. And there's our door. in the model. And you can see the 2D symbology. So you now have another door panel that can be used within your curtain wall system as part of the library.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.